bad news and a bunch of good jokes about diaper Twitter tubby. You can probably figure out from the initials who I mean. So there were a lot of good jokes and a lot of bad news. So I'd like to switch that around so that I can say today that I have some good news and I'm going to have a lot of bad jokes. So the reverse of last year. So the good news is I'm about to retire, which I'm really excited about. And the bad jokes will follow shortly. I'd like to thank Kevin for inviting me. I think that, of course, implies that he doesn't know me very well, or he wouldn't have invited me because the disaster that's about to follow. But anyway, I'm happy to be able to rant away for a bit. And I do want to congratulate all you sick bees for the coverage in science. I was actually in Ecuador during the sick bee time, but anyway. All right, so I'm going to share my screen, see if that works. And share, and I think I'm good. So this is going to be about courtship displays of golden wing mannequins, work that Liam, who's present, was in on, some of the important stuff, and my grad student, Nick Oakley. And the study site was right around where the queue is there in Quito in Ecuador, Milpe Reserve. So I'm going to start kind of at the beginning. So the disaster is about to start. Let's see. There we go. So I was born in Trinidad, actually Trinidad and Tobago, which may explain some of my personality disorders. And I was born before David Snow and Alan Lill did their classic work there on mannequins. Let's see if there we go.
Take me, I am feeling lonely. Take me down to Low Zero, but don't let me mother know.
So I'm not actually related to Khrushchev, despite the photographic evidence, but that is Trinidad, and that's calypso music, which I love. And then later moved to Rio de Janeiro, and here I am as a kid with my brother, staring up at the birds in the trees at the botanical garden. And
Cachimbo da vovó, mamãe sassará, não tem fumo, só quem coma, mamãe sassará.
So music, there's gonna be a little music through here. Unlike usually, it's gonna be actually good music because it's from Brazil and Latin America mostly. So no Ramones in this talk. And there I am early on, and not much has changed in the intervening years. Here I am more recently, still staring up at the birds in the trees. But my career has had one startling discovery. So here's a recording from my parents' 50s Brazilian collection. Someone who actually sang on the soundtrack of the classic Brazilian black and white Bonnie and Clyde movie from the Bandit Northeast.
Olé, mulher rendeira. Olé, mulher renda.
About 20 years later, that song floated upstream up the Amazon to Iquitos, Peru, where chicha music was born, and this song came out.
Olé, mujer hilandera. Olé, olé, olé. Tú me enseñas a hacer hilo, yo te enseño a enamorar. Tú me enseñas a hacer hilo, yo te enseño a enamorar.
And really cool because they just heard what they heard and turned it into Spanish instead of Portuguese. So the words are sort of phonetically transcribed, sort of. And 20 years after these guys had done the Iquitos Chicha version, I connected the two and realized, oh my gosh, this song that I knew from my parents' record collection was the same song. So there I am in the throes of musical discovery. All right, let's see, I keep not being able to advance. There we go. So 2008 was a big year for me. I went back to South America, actually mostly in parts of Argentina with no mannequins, but got up to Misiones at the end of that time, saw a couple of species I'd never seen, and
Gracias a la vida que me ha dado tanto.
so I want to thank a bunch of people. Bayana System, my current top favorite band. And thanks some guys. So, and I mean, I'm feeling guilt here because I didn't put Doug Levy in there, et cetera, et cetera. So it's not whether or not you contributed to my wonderful place in life. It's about my failing neurons. No genes or neurons in the stock. And I'm becoming fairly neuron free. All right, so that 2008, I got a lot of help along the way, and I've seen a lot of mannequins, but I've still got 8 to go. Here's my little list. Mike and I were just talking about the Gran Sabana of Venezuela, which probably isn't a go, but there's some. But these systematists keep splitting things, so I got to go see a new Machairopterus, the painted mannequin in Peru. I've been near there for another one in Neopelma, but anyway, so life's pretty tough, obviously, but I still have this quest to go, and some of it could be a little difficult.
You can't always get what you want. You can't always get what you want.
But I did get a lot of time in with Masias in Ecuador, so let's just start with some video of them displaying. Here's a clip at Milpe. Bow, 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 bow. Female doesn't seem all that excited. Bow, 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 bow. A lot of those. You'll see that as a theme. No, his sidekick came in. Bow, bow. ALAD. So that's audible log approach display, where they zip into the log, a lot like Corapipo. In fact, I'll talk about that in a bit. Let's see that in slow-mo, and this is very obtained at great difficulty because I was going to kill him if he ruined the Edgertronic camera we used to film it. This is filmed by Nick Oakley. So here is coming in from the right, flips. 1, 2, 3 flaps. If there were a female, He'd have landed facing her, flipped in the air, and faced her again. Let's just go back and watch that one more time. He'll come in from the right again, flip. Look at that gold, top and bottom surfaces of the wings. Really great. Okay, so that's wonderful footage by Nick Oakley. And by the way, retired, I'll be footloose and fancy free, so I would love to come to your study area and film whatever you have in high speed color. All right, I gotta do something again here to keep going forward. Okay, now we're gonna see a little clip of a human gymnast doing sort of the same thing. Full front, half twist with
Awesome.
layout. She does it a little slower than the mannequin because she's using gravity and he's using powered flight, but basically the same maneuver in gymnastics. Okay, so I'm going to sort of address two questions. Is behavior always complex, or is it sometimes simple? So recently, Jack Bradbury and Sandy Varenkamp in 2014, and Eileen Hevitz and Gail Patricelli, 2016, have argued that, you know, complex behaviors are just a piece of the natural world and they require analyses that can capture that complexity. But sort of the theme of this will be that sometimes simple works. Simple may actually be more successful. Another big theme in behavioral ecology behavior is whole thing of animal personalities behavior syndromes. So huge topic, and the idea is that there are consistent, context invariant differences among individuals. For example, an individual is bold in all contexts or shy in all contexts, and that those may override the particular context, for example, foraging or courtship. And I'm going to have three contexts for analyzing these Masias displays. Males present, one or more, but no females. Mal, that'll be in blue often. One or more females present, femme, that'll often be in red. And then during the display, there was one or more copulations, cop, and that'll be mostly in gold, though sometimes it'll be in black for reasons that are obscure. So which explanation best explains variation among Masias displays, among different displays that we filmed in video clips? Is it individual variation? In other words, is most of the variation due to the identity of the male, or is it dependent on the context, mal versus femme versus cop? I don't want to spend much time on this, but it's just a way of getting at this idea that simplicity may actually work. Success maybe sort of go along with simplicity. And this is a network, an ethogram. The nodes in a social network, you usually have individuals, Johnny, Freddie, Susie, Billy, Bobby, but here the nodes are individual behaviors. So it's like an ethogram, elements of the behaviors connected by how the flow in a sequence, a video sequence goes. And really all I want to do is just say, look at the mal network. This is the composite of all the bouts where there were only males present. Density is very high. There's a lot of edges, 145 edges. And something called the effective degree is very high. Effective degree is actually exactly the same algorithm as effective number of alleles. If there's one allele that is dominant in frequency, then you'll effectively have very few alleles. 90% of the alleles are allele A, then you'll have 1.2 or 1.3 effective alleles. Effective edges, same way. A lot of effective edges here, but look at the COP network. Not very dense, not very many edges, and a very low effective degree. Effectively, because bows are so frequently, bow, 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 that we saw in that clip, and neck twists, neck, 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 neck. Effectively, those are the two main ones, and all the rest add up to about one edge, effectively, as in effective number of alleles in population genetics. So the MAL network's really dense, tangled, complex, higher effective degree. COP network, simpler, lower effective degree. And I'm going to leave that at that because I want to spend a little more time on some of the other measures. But here are those bow loops that we saw in the video. Bow, 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 bow. And these are actually not, it's a sort of logarithm of the, because otherwise that would take everything over. Okay. Most of the rest of what I'm going to talk about is looking at the courtship displays as strings of behavioral elements, the bow part, the ALAD part, the neck twist. And here are the four most important ones. What we call an ALAD, the audible log approach display. Can abbreviate that with the letter A, side-to-side bows. Abbreviate that with the letter B, head down bow, another thing they do. H, neck twist, N. Those are the four most important. So we could form this string of elements. The guy did bow, 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 ALAD, head down, bow, and then a bunch of neck twists, okay? And I'm going to do two kinds of analyses. Compressibility in contrast to, and I'll argue for it, in contrast to entropy, and gyro distances. Compressibility is really important in computer science. I'll talk about it a bit more in gyro distance for record matching. Record matching, I've never even heard of this sort of the discipline, but there are conferences with 2,000 people trying to do record matching, and we'll see that. I don't think either of these, but correct me if I'm wrong, if you've seen compressibility or gyro distance used in behavioral analysis, I'd be interested. I haven't seen it. All right, we're going to start with entropy. Entropy can be measured various ways, but Shannon information entropy often is done in bits. And entropy is a measure of the disorder. High entropy is a disordered system with randomness or surprise, okay? So a random jumbled sequence of elements has high entropy, whereas a highly ordered or high repetition sequence of elements has low entropy. And the reason I bring in the entropy is because I'm going to sort of twist what's been done, come to an opposite conclusion of what's been done in the song literature, which is entropy has often been used to analyze sequences of syllables in bird songs and conclude that high entropy is good. So the high surprise element of songs in the song repertoire has been linked with high mating success in birds. Here are the data for entropy for the three kinds of bouts: the MAL bouts, the blue triangles, FEM bouts, the red circles, and COP bouts, the square black squares. And really the pattern is fairly simple. Depending on the number of distinct behavioral elements in the bouts, you have a maximum. So let's take 8. If there are 8 elements, the maximum possible entropy is the log base 2 of 8, which is 3. 2 to the power of 3 is 8, okay? And what we see is the male bouts, MAL bouts, often approach the maximum possible entropy, okay, of 3 for 8 elements, and it's 3.58 or something for 12 elements, okay? But the COP bouts have much lower entropy. So the COP sequences are down here with low entropy and not much surprise, less randomness or surprise, okay? So that one's useful and was a good entryway into things, but I'm going to introduce the alternative idea of compressibility. So entropy assesses only the frequencies of the elements. So this string, which is obviously very patterned, has exactly the same entropy as this next string, which is a random shuffle thereof. Okay, so the entropy is the same for these two strings of elements. But the second one is obviously more sort of random. Okay, and what we might like to take into account is the importance of order. So some compression algorithms, it turns out, take account of order. Now, if you use the internet, its GIFs are lossless compression, JPEGs are a compression with loss. The compression I'm going to do here is pretty similar to GIF compression. So one way to do lossless compression is first do Huffman encoding. This is really cool. This is a grad student at MIT, Shannon, and another famous MIT person had struggled with a good way to encode things. One of the two gave Huffman the choice of solve this problem or take the exam. And overnight, this grad student, master's student, solved this problem by using something that neither of the others had thought of, a binary taproot tree. It's actually a sort of a network to start your coding. It's really a cool thing. I don't have time to go into it. And the second is two Israeli engineers types, computer science types, live in Zempel 77, 78, came up with a sliding window. You look across this sequence here and you see, oh, we get some, things that are repeated. And we can compress that way. And there is actually an R package, Brotley, that does this Huffman encoding and then the LZ77 compression and looks for motifs and repeat elements, okay? So it would also pick up that there were some ACHKDs scattered through a sequence and compress them more. And I think that this compressibility, if we look at the three bout types, mal bouts are not very compressible. They're jumbles, they're sort of random sequences, whereas cop bouts are highly compressible. Okay, and it turns out that the difference between the compressibility of mal bouts, we can't really compress them down. The original sequence is about as long as the compressed sequence. And in the cop bouts, the compressed sequence is much shorter because we have repetition and we have motifs, okay? So highly significant difference between those two in a t-test. All right, so, and I might get back to it, but there's some analogs there for things that one would be interested in, for example, in genomics. So that'd be a fun thing to talk about. Here's where it really gets closer to sequence alignment and various things. And this is to get at the idea of, is individual variation, animal personalities, behavioral syndromes more important, or is context more important? And the analytic tool I'm going to use here is something called the Gyro Distance. And it goes from 0, very dissimilar, high distance between the strings, to 1. 1, the strings are identical. So it's a measure of, how similar they are, going from similarity 0 to similarity 1, okay? And this was developed to match census records. So let me give a little example. It's asking the question, how different are two strings? In our case, our strings are A, G, C, H, and the display, the one letter display sequence is from our videos. But originally it was to look at these records: Mr. Jason Jones, Laramie; J. Jones, Cheyenne; Jason L. Jones, Laramie, Wyoming. Are those two more similar? Should they be grouped? Might we get income data there and residence address or phone number there? So you go through all these different possible records of the same person, J. Jones, but we see that Cheyenne is different there. So that's where the That's the motivation for developing the algorithm. And really it does the number of matching elements in the string and the transpositions required. So there's some similarities there to sequence alignment. There's some huge differences also. All right, let's look at 3 example strings. This could be my display sequences, F, 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 A, G, H, H, H. This next one is pretty similar to it. We would just visually agree. These 2 are pretty different. So if we were doing gyro distances, these 2 would have a small gyro distance because they're very similar. These 2 would have a large gyro distance because they're very dissimilar, okay? So if personality is more important than context dependence, then what we would expect is that comparing within an individual, his display strings should be more similar to each other. So within individual distances, for strings of his displays should be small, whereas we go across individuals, between individuals, the distances should be large. So within should be much smaller than between distances. So here's a plot of that expected thing under the personality is the big thing. In that case, within a male, whether it's his Malbouts compared to his other Malbouts or his Cop-Bouts, the distances should be small. They should be pretty similar. Whereas between males, whether they're Malbouts or Cop-Bouts, the distances should be large. So it's all about whether we're looking within a male, comparing his own strings to his own strings, similar, between males, different. Okay, that's the expectation. However, if context is more important than personality, then within context distances should be small. Cop should be similar to Cop, but between context distances should be large. Mal should not be very similar to Cop, and within should be more or less similar to between patterns. That's what we get. Whether it's within a male's Malbouts or between males' Malbouts, Malbouts are relatively similar in their gyro distances, and they're pretty different from each other because they're different jumbles of things. Whereas Cop-Bouts, whether it's within a male, his Cop-Bouts are pretty similar to his other Cop-Bouts. His Cop-Bouts between males, a male's Cop-Bouts are actually very similar to other males' Cop-Bouts. In fact, to me, the coolest thing is that a male's own Cop-Bouts are more different, higher gyro distance from each other than his Cop-Bouts are to those of other males. His Cop-Bouts look more like those of other males than his own Cop-Bouts look like his. So male's own Cop-Bouts, higher gyro distance, less similar to each other than his bouts are to those of other males. So it's all about Cop-Bouts. Doesn't really matter the identity of the male. In fact, his are more similar to those of other males. It's all about context, okay? Bouts are similar if they're in the same context, Cop, Cop, Mal, Mal. So first we have simple, whether we're looking at networks, entropy, or compressibility. Simple succeeds. So Cop display sequences have much less dense and jumbled etho networks, lower entropy and higher compressibility. And that's kind of the opposite of the birdsong literature, because in the birdsong literature, more successful singers perform bouts that have higher entropy. So why might there be this difference between the song literature and what I'm showing for display sequences in Masias? Well, it might be the difference in sort of the function of the repertoire. Songs as threats. I have a huge arsenal of songs. Don't even bother to mess with me because I can do all kinds of things.
Surprise, 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 surprise. Ain't nothing strange to me.
Okay, so that's the Stones with song literature. Courtship, on the other hand, might be enticement. Surprises might not be a good thing. So lower entropy for success. So the cop-outs aren't really a matter of getting it right, because the same males who copulated could do a copulation bout where, quotes, they got it right and it was all orderly and so forth and simple. But then if they did a mal bout, it was back to high entropy or a fem bout. So it wasn't that they got better at doing it and then their mal bouts or their fem bouts got better. It was all about the context. They do something different when there's just other males or just by themselves than they do if there's a female present, and even more different if it's going to get to a copulation. I think that is a feedback between male performance and female reaction. So the differences are a matter of context. Males perform differently when females are present, and even more differently if the female is likely to copulate, I think. So some males do display better and females return there to copulate. So there is this feedback between male and female behavior. Let's see. And going back to context, as seen in the gyro distance stuff, overrides individual identity. So a cop is a cop is a cop. I'm badly paraphrasing poems. Or a cop by any other male is the same as a cop by this male. So a male's own cop sequences are very different from his own mal sequences. Big difference between gyro distances of cop versus mal, whether we're looking within or between males. They're more similar to the cop sequences of different males, not identity, than they are to his own. So some playwright in some play said the readiness is all. Another great playwright said the context is all. It's all about the context. So some conclusions. Maybe nature's simpler than we think. These Masias displays are highly repetitive when there's a cop, lots of bows. They have repeated motifs, bow, 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 A-lad, neck twist. Do it again, bow, 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 A-lad, neck twist. Repeat those things. So context matters, and here's a lesson for giving talks. Behave appropriately for the occasion. So, for example, if I'm lecturing to UW undergraduates, distinguished group of people, I'll wear a suit. However, if I'm addressing Manikanistas, the Manakin Mafia, I might want to try to fit in with the crowd. I'm trying to grow a beard, Kevin, really I am. So if you're addressing a tough crowd of Manikanistas, try to blend in. Behave appropriately for your context. There, very, very important. Okay, some ongoing questions. So maybe we have time for discussion and thoughts about this. And this is very hand-wavy, very somewhere from the fevered brain of Dave McDonald. A lot of stuff about machine learning for recognizing faces in different contexts, et cetera. But I think maybe what we want is some rules for process. So, and I have no idea whether this would work, but I'm wondering if we combine some of the sort of machine learning kind of approaches with the idea in exponential random graphs. So it's a branch of network theory. What exponential random graphs try to do is come up with a few simple rules that explain the buildup of a network. So could we sort of machine learn how they do it, what the differences are, recognize sequence of displays without knowing whether a female is there or not, and then extract some rules from that network? And if we put those two together, blue and yellow equals green. See, boy, am I a color theorist. Liam, tell Rick Prum that I'm very up on color processing. So does repetition, and another sort of question, does repetition is bow, 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 and skillful attention to female reaction, because there are females there in the fem bouts, but in the cop bouts, they get a little bit different. Maybe the males are reacting appropriately to the different context of a female who is receptive versus who is not. And maybe somehow in those ones where the female is getting more receptive, there's suspense that's resolved by the ALAD. Bow, 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 she's waiting, bang, she's ready, do the ALAD, copulate. Another one I've wondered about, and this would be people like, well, Doug's probably gone by now, but ultra rapid displays that we're seeing in so many of the species. Could there be adaptive value in other contexts? Nat Wheelwright, for example, has looked at risk to frugivores of trees. Various people have. Those fruit trees are really predictable resource patches, and maybe predators are queuing in on them, and those snappy, rapid moves the males do could be useful as an evasive maneuver in the context of feeding on fruit. I don't know, have to film some frugivores being attacked at fruit trees and see if they use snappy, rapid maneuvers. That might be fun. A next step, some of the Courtship Mafia may be present at the talk, and we're gonna have a lot of fun because Courtship sister clade to Masias, and we're going to look at Courtship displays with some of these same tools. That's going to be really fun. Looking forward to that. And another one that I'd like to do, we have the data, didn't do it for Nick Oakley's thesis, but we have the data on female behavior. So this idea of, how are females reacting as males do different things? That'll be a really fun thing to do. I think, já faz tempo que eu saí.
Já faz tempo que eu saí de casa pra viver no mar. Já faz tempo que eu saí de casa pra viver no mar.
Time for me to leave the house and go out into the ocean of possibilities under retirement. Wonderful group, and again from Brazil, Neste Ambrosio. Thanks a lot. I think I might be done. Questions, arguments, fights?